For continuous graphs, to decide if it's a function or not, we're going to be using something called the vertical line test. Okay, now we can also use this for a discrete function if it's graphed, so it will also work for that. But again, this is going to tell us if our relation is a function or not. So if the vertical line goes through more than one point of the graph, it is not a function. Okay, so let's do an example real quick. So let's say we had a graph that looked like this. Let's make it just kind of a upside down U this time. If I can take and draw a vertical line through it, and it only goes through once, so it's going through once right about there, this is a function. Now let's take another graph. So let's say we have something that looks like this instead. So let's do a sideways U this time. Okay, so something that would look like this. If I take and I draw a vertical line through this, and it can be anywhere, so if I do it right here, it's going to go through the graph in two different points. So we have it's going through here and here. So if that's the case, that means if we actually find those x values, we're going to have a repeated x value. So this is not a function. Okay. So that's how we're going to use our vertical line test. So let's do some examples, and we're also going to practice domain and range because that can be a little tricky for continuous graphs. Okay, so for our next set of example problems, we're going to use the vertical line test to decide if it's a function, and then we're going to state our domain and range. So first thing, let's do our vertical line test. So if I take and I draw a vertical line, I'm looking to see how many times it goes through. So it looks like it's going through once, twice, 3 times. So that means that this is not a function. Now we can still figure out our domain and range, but again, the way that we write it's going to look a little bit different. So it's no longer going to be a list of numbers unless we have a discrete graph, so just a group of points. So as I'm looking at this, we have to remember what domain is. Domain is all of the x values. So we have to decide what x values are on our graph. So the easiest way to do that is to look at the horizontal expansion. So is your graph going to the right? Is it going to the left? So if I'm looking at this, these arrows indicate that this graph is going to continue on forever and ever and ever. So if I'm thinking about all the possible x values in this, I'm going to get every single one. So there's nothing on this side of my graph. There's no x's that I can't include. Same thing on this side. This graph is going to continue to expand to the left forever. That means that on this side of my graph, I'm going to have all the negative x values, and we have 0. So for our domain for this one, it is all reals. So there's a couple ways that we can write this. So all reals like this. Now if we go back to our definition of our number groups, the real set of numbers has that kind of bolded R, so it looks like this. So that is talking about all reals. We can also use interval notation to describe our domain. So if we use interval notation, we have everything from negative infinity to positive infinity, and then we would have parentheses because we don't include infinity in our brackets. Okay. So one of these 3 ways is how you need to write the domain for this problem. Now continuing to look at this, so if we switch to range, range is all of the possible y values. So again, for a continuous graph, the easiest way to think of this is going to be our vertical expansion. So is our graph going to continue to increase forever? Is it going to continue to decrease forever? That's what you have to decide. So on this side, even though it's going up very slowly, it is still going up. So at some point, it's going to get to all of our positive y values up here. Same thing down here. It's decreasing very slowly, but it's still decreasing forever. So that means at some point, we're going to get to all the negative y values. So there aren't any y values that we need to worry about excluding. So again, to write this, there's 3 different ways that we can write it. All reals, our symbol, so the little r, bolded r, or again, we can write it in interval notation. So from negative infinity to positive infinity. Now, as we continue, I'm going to be continuing to write this here, all reals, or in interval notation. All right, our next example, again, so let's start by deciding whether or not this is a function. So I'm going to kind of pick a space and just draw a vertical line through it. So it's going through one time. So that means that, yes, this is a function. And now I have to decide my domain. So again, domain is our horizontal expansion. So will our graph continue to the right forever? Will it continue to the left forever? And the answer to those questions is yes. So that means that our domain is going to be all reals. Or again, interval notation, it goes from negative infinity to positive infinity. So range, next one. So again, this is our vertical expansion. So does it go up forever? Does it go down forever? So as I'm looking at this, on both sides of my graph, this is going to increase up forever. So that means that we're going to have all the positive y's all the way up to positive infinity. But if I'm looking at this, I don't have any graph down here. It's not going below whatever this point is. So this point right here, this is my smallest y value. So I need to figure out what that is. So if I find this point, it would be at 0 and then negative 2. So negative 2 is the part that I care about since we're looking at the range. So that's the smallest y value that I can have. And because this is a closed circle on our graph, that means that we can include it. So for my range, it's going to be everything, so y, all the y's, greater than or equal to negative 2. Now if we switch that to be an interval notation, so our smallest number is negative 2. We're going all the way up to positive infinity. Negative 2 is included, so we have a bracket, parenthesis around the infinity. All right, next one. So again, doing my vertical line test, it doesn't look like I can find a place where it goes through more than once. So that means that this one is also a function. So domain, if I'm looking at my arrows, it's going to continue to go to the right, continues to go to the left. So that means my domain is all reals. So again, interval notation is from negative infinity to positive infinity. The range, again, I'm looking, is it going up forever? Is it going down forever? And again, yep, on this side it continues to go up. This side it will continue to go down. So range is all reals. And again, the interval notation is from negative infinity to positive infinity.